Hello everyone. In this lesson, we're going to do a couple quick examples for 4.1 on discrete probability distributions. So the first example is, let's say that we have T, which is we're going to flip a coin and we're going to observe whether we see a tail or not. This means that we have two possibilities. So our sample space would be that we see no tails or we see one tail. And now what we're going to do is we're going to figure out what is the expected value or mean of flipping this coin, what is the variance and standard deviation. So for our outcomes, we're first going to write down what are our possible outcomes. Well, we can get a 0 or we can get a 1. And then we're going to write down the probability of these different outcomes, tails 0 or tails 1. So because this is a fair coin, my probability of getting a not tail, which is heads, would be 0.5. My probability of getting an outcome that is tails is 0.5. So my expected value would just be, which of course is equal to the mean mu, would be equal to my outcome 0 times the probability that I get that 0 of 0.5 plus my outcome 1 times the probability that I get a 1, which is getting tails. And of course, 0 times anything is going to be 0. So this is going to leave us with 1.5, or 1 times 0.5, which is going to be equal to 0.5. Which just means that if I were to flip a coin many times, that I would expect some heads, I would expect some tails, but as I start to get into the law of large numbers, I would expect there to be as many heads as there are tails because I have a 0.5 probability. So on average, I would expect an outcome right in the middle, right? Half heads, half tails. So I would expect 0.5 tails on any given flip, which of course I get in a specific, when I'm flipping the coin right now, this is not really giving us a lot of information, but what this is telling us is where the center of the data is. The center of the two outcomes is 0.5 because these are equally likely. Now, if I had a weighted coin where one probability was higher than the other, in this case, it would tell me by having a expected value that is closer to 0 or 1 tails, it would mean that I am more likely or less likely to get a tail when I flip this weighted coin. So now let's find our variance. Our variance, if you remember, is going to be equal to our outcomes x minus our expected value, or our mean, squared, times the probability of those outcomes, and then we will just sum them up. So in this case, we have two outcomes, so this is going to be 0 minus 0.5 squared times our probability of getting a 0, which is 0.5, plus our outcome 1 minus 0.5 squared times our probability of getting a 1 or 1 tail, which in this case would be equal to, right, so 0 minus 0.5 is going to give us negative 0.5. Negative 0.5 squared is 0.125. 0.125 times 0.5 plus 0.125 times 0.5 would give us 0.25. And then from there, if I wanted the standard deviation, I could just take the square root of 0.25, which is going to give me an outcome of 0.5. Meaning that when I flip this coin, on average, I expect to get 0.5 tails, give or take 0.5 tails, meaning that I would expect most of the time it's going to be 0.5 above or below this value 0.5, which would give me 0 tails or 1 tail. Now this example is not the most illustrative of what we're talking about. So let's take it one step further. Let's say now that instead of looking at tails, we're going to look at heads just to kind of differentiate. So in this case, we're looking at heads. We have H, and we're going to be flipping 4 coins. So our outcomes for number of heads would be what? Well, if I flip 4 coins, I could get no heads. I could get just 1 head. I could get 2 heads. I could get 3 heads. And I could get all 4 of them to be heads. So having 4 coins means I have 5 possible outcomes. 0, 1, 2, 3, or 4 heads. So then if I were to draw my table again, this would be 0, 1, 2, 3, 4. And then my probability of getting that many heads would be, to find our probability of getting these number of heads, we first need to figure out what is our total number of possible outcomes. So if you remember from our multiplication rule of counting, our total number in outcomes is going to be the number of outcomes in every given step, and then you're going to multiply them out by each other. So when I flip my first coin, there are two possibilities, heads or tails. My second coin, heads or tails. So because each of them are a coin, n1 is equal to 2. N2 is equal to 2, N3 is equal to 2, N4 is equal to 2. Now, because they're all the same outcome, this is the same thing as saying that I want 2 to the 4th power, which is going to be equal to 16 possible outcomes. Now, my probability of rolling a 0, or my probability of flipping a 0 when I flip 4 coins is how many ways can I get 0 out of the total 16 flips? And that would be one way, because it would be all of them are tails, right? Because I have 0 heads, which means this would be 1 out of 16. Now, to make this easier, what I'm going to then do is I'm going to go focus on what's the probability that I get 4 heads. Well, just like before, I have one way that I can get 4 heads. They're all heads. So this is going to be 1 over 16. Now let's look at how many ways can I get just one head. Well, there's 4 of them, right? I could get ahead on the first flip and no other flips. I could get ahead on the second flip, but no other flips. I could get ahead on the third flip and no other flips, or I can get ahead on the 4th flip and no other flips, meaning that this will be 4 out of 16. Likewise, my ways that I can get 3 heads would also be 4 out of 16, because if you kind of wanted to rethink this problem, if I get 3 heads, that's the same thing as saying I get 1 tail. So how many ways can I only get 1 tail? Like I get 1 tail in the first flip, or the second flip, or the third, or the 4th. There's 4. Now for the last one, you could go through and look up all the ways you could get 2 heads. You could say, okay, well, heads, heads, tails, tails is one. You can get heads, tails, that's another one. You can get heads, tails, heads, that's one. You can get tails, tails, heads, heads. You can get tails, heads, tails, tails. You can get tails, heads, heads. I think I might have already said that one, which will be 6 out of 16. Or what you can do is you can use the fact that all of our probabilities must sum up to 1, meaning that if I have only one probability left, I know that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of my 16 outcomes already accounted for, meaning that there are only 6 outcomes left out of those total 16 outcomes. So now I have my probability distribution. I've got all the outcomes. I've got all of the probabilities associated with them. Now let's find our expected value. So our expected value of of heads, h, which is equal to mu, is going to be 0 times the probability of getting a 0, 1 over 16, plus outcome 1 times probability of getting a 1 is 4/16, plus 2 times 6 over 16, plus 3 times 4 over 16, plus 4 times 1 over 16. And doing this, I'm going to get 2, which means that every time I flip these 4 coins, on average, I expect the outcome to be 2. So on a given coin flip, I expect that I would get 0 about a 16th of the time. I would get a 1, 4/16 of the time, or about a quarter of the time. I would get a 2, 6/16 of the time. I would get a 3, 4/16 of the time, and I would get a 4, 1/16 of the time. But if I were to repeat this experiment over and over and over and over again, the average of all my outcomes I would expect is 2. So now let's set up our variance. So our variance is going to be outcome 1, which is 0, minus that mean 2, square that, multiply by its associated probability, plus 1 minus 2 squared times 4 over 16, plus 2 minus 2 squared times 6 over 16, plus 3 minus 2 squared times 4 over 16, plus 3 minus 3 squared times 1 over 16. Now, I'm going to actually leave this for you to calculate, but before I actually move on to the final example for this section, I do want to point out that this middle term here, 2 minus 2 squared, well, 2 minus 2 is going to be 0. 0 squared is still 0. This term actually goes to 0. So you actually have to do 4 calculations to figure this one out. Once you have this value, you can find sigma by just taking the square root of whatever value you get here. You just take the square root, you take this value, you plug it in, and you've got your standard deviation. So try to do this on your own. For our last example, we're going to be looking at a raffle. So in this raffle, we're selling 2,000 tickets. So N is equal to 2,000. And what you have to do to get one of these tickets is you need to spend $1. Now there's some prizes for this. In this case, the prizes are you can win $1,000, you can win $500, you can win $250, you can win $150, you can win $50. Or if you don't get one of these tickets, then you get $0. So these are all the possibilities for your raffle ticket. So now we actually need to take into account though that if I win $1,000, I actually didn't get $1,000 because I spent $1 to get that ticket, meaning that I actually am winning $999. This one would be $499. This would be $249. This would be $149. This would be $49. And if I get $0 back or I lose, I get minus $1. Okay, so now what we're going to do is we're going to create a table of our raffle tickets, which in this case would be our outcome X, how much money we win. So we'll put 999, 499, 249, 149, 49, and minus 1. And we will then put our probability of each of these outcomes. So this one we kind of made simple. You could have some raffle where you have like one $1,000 ticket, two $500 tickets, something like that, but we're just doing it where there's one of each win. So this means that 1 out of 2,000 of these tickets, you win the $1,000. 1 out of these 2,000 tickets, you win $499. 1 out of the 2,000 tickets, you win $250. 1 out of the 2,000 tickets, you win $150. 1 out of the 2,000 tickets, you win $50. And then of course we had 5 winning tickets, meaning that we had 1,995 out of the 2,000 losing tickets. So to find the expected value of this, I would just take expected value of X, which is equal to mu. And this is going to be the fact that if spending $1 to get a ticket, I get $1,000, that means I've won $999 times my probability of getting that $1,000 winning ticket, 1 over 2,000, plus 499 times 1 over 2,000, plus 249 times 1 over 2,000, plus 149 times 1 over 2,000, plus 49 times 1 over 2,000, minus 1 times 1995 over 2,000. And then with this, I would get a total of minus 0.025. So what does this mean? Well, first of all, think about the fact that this is money, and this is a probability, meaning that I would expect to lose, on average, about 2.5 cents for every raffle ticket that I buy. So if I were to buy 10 raffle tickets, I would expect on average to lose about 25 cents. It does not mean that if you buy one raffle ticket, you lose 2.5 cents. You either gain $999, $499, $249, $149, $49, or you lose an entire dollar, right? There is no 2.5 cent outcome. So on any given raffle ticket, these are your possible outcomes. But if I were to repeat this over and over again, let's say that there was a raffle every single day for the rest of eternity, and you get one raffle ticket that you buy. This means that on average, I would expect, sorry, this is negative, I would expect to lose 2.5 cents. So if I had some starting amount, let's say I had $1 trillion, that means that every day I would win some, I would lose some, but overall I would lose far more often than I win. So just like the poker example I talked about in the actual lesson, I would expect on average that this is actually a losing proposition. Buying these raffle tickets is actually costing me money. Thank you for watching. To continue learning, click the linked video here for the next lesson. If there's a topic you'd like me to cover, let me know in the comments. Don't forget to subscribe, and I'll see you in the next video.